So my name's Deep, and I work for Alliance Health Networks, which I'll talk a little bit about in a second. And I'm going to chat a little bit about mining unstructured healthcare data, medical research abstracts, and online web. So with that, let's down arrow. Okay. So just a little bit of background on Alliance Health Networks. We are a company of about 80, 85 folks. We have a number of online health properties, one of which is Medify.com, which targets healthcare practitioners and advanced patients online. That's the one I'm going to spend the most time talking about. It's the one that's got the most rich. And in the past year, we've seen about 10,000% user growth, so it's been a pretty good year for us. Our demographics are about 70% healthcare professionals and 30% advanced patients, and of HCPs, the majority are physicians. Other than as far, yep.
Advanced patients, do you mean patients who are very
It's patients, I guess the simplest definition is it would be patients who wade through Medline and stuff like we present. So that's probably the most accurate definition. But yeah, from what we understand, there are folks who are willing to like really try to read these things and understand a lot more depth than what you find in WebMD. Properties. So we have a number of condition-centric properties. One of the main ones is Diabetic Connect, which right now is the #1 online diabetes site with approximately 1.4 million uniques. And monthly, and so those are online discussion forums with some guided health folks who kind of help people address some emotional needs as well as seek kind of an online support community. And then the largest part of our business is a matchmaking service between patients seeking advanced treatments, devices, or pharmaceuticals, and so, oh, and just jump in whenever. I like questions and being interrupted. So I guess the first question to establish a little bit of motivation is why even mine healthcare text data? What's the point? So one of the things I'll talk a little bit about is how do people currently get their information online with respect to health? So if you think about usually people, you get to Google at some point, you enter a query, and you usually wind up on one of these sites. WebMD, drugs.com, Yahoo Health. These guys started around 1998, 99, 2000, and they haven't really evolved much since then. They have these 5 kind of pillars of the sites, as I call them. One component is a question answering component. So this is, like circa Yahoo Answers 2000, folks go in there, ask a question, people give answers. And this component is good in the sense that, so I'll talk a little bit about the benefits of this approach. One of them is its original content. So because people are directly entering information, that original content gets a lot of love from Google and other search engines. And they also align well with Google searches, so people tend to enter, ask a question oftentimes in a similar way to the way they might. Alignment helps a lot. And if people are seeking answers, and if they can't get evidence-backed answers, then they'll take other answers that seem like answers. Whether that so that's another advantage. All these sites have some kind of topic page, so that would be like treatment, condition pages, and they're typically head-focused, meaning they're the most popular, frequently occurring treatments and conditions. And because there's a huge manual emphasis on these sites, they're actually manually writing this content, and they've been doing so for years, and oftentimes it hasn't changed much. They change it just a little bit so that the search engine optimization stays. We're gonna this a bunch. The other kind of main component is some sort of news and media component. So a lot of times these folks are publishing articles, and that's to get kind of people continuously coming back. So that fresh content is a key element. And they also have, experts I put in quotations. These aren't typically, these aren't the world's experts of anything, really. They're folks who might have a title and show up and get paid a little bit, and then they write some content. I would classify this as like moderately authoritative, but it is easy to understand, and it does have good coverage in the head. And then, of course, they have discussions which help address some of the emotional needs and has a lot of the other characteristics of these other sites, these other kind of building blocks. And what's the problem here? Basically, if you look across all of these, this manual entry, editing of these topic pages, this manual construction of news articles, and this manual contributions by experts, it's very expensive. It costs folks money. And despite these being pretty large businesses, WebMD is about a $300 million a year business. That's still, forces them to kind of be head focused in terms of relatively small number of treatment and condition permutations. And that's important. That's significant because, at about 4,000 treatments and about 4,000 conditions, and many treatments span many conditions, and most treatments span a few conditions, wind up with a pretty large set of permutations not addressable by this approach. We talked about authoritativeness. There also, a lot of times, this content is old and dated, and not terribly statistically meaningful. When you think of answering, you ask a question, whoever it is that chooses to answer your question answered your question. So that's, maybe a data point of one, maybe a couple. So our answer is some automated content generation approaches. So we go through and we spend a lot of energy doing some fairly involved text mining, and then once we bring structure to this unstructured. Basically, with automated content generation, we don't need to scale the number of writers. We do need, or a small team of technology folks who know what they're doing, but it's a much more cost-effective. It's statistically based as well. So, when we show certain conclusions that are repeatedly being made by healthcare experts in the form of research articles being published, or when we show repeated examples of symptoms or side effects being experienced by forums, it's really this kind of bubbling up process that helps to kind of lend confidence in the fact that that symptom or side effect scales to millions of patients. So whether it's a large pharma company running a large clinical trial across thousands, in some cases tens of thousands of patients, whether it's academic researchers that are able to pool some money and get more patients, or whether it's just the millions of patients who online are discussing things every day. And it also scales to long-tail treatments and conditions, which I'll describe more. Authoritative and citation-driven. So our approach is that every single thing we present, because it's in part because it's subject to statistical error rates, we want to make sure that folks get in and actually get to the root data. So we're never trying to optimize, or we really want them to get in and read the research studies if they, easier for them to get there. And similarly, if we're concluding something based on discussion of patients, we want them to get in there and actually see the discussion, the errors that inevitably occur with this process. And of course, because it's automated, once you plug into our data feeds, which is daily, or our crawls that are picking up discussions online, that content is fresh, and we're able to keep it fresh because it's flowing in all the time. So, so how many of you guys are involved with, like, everyone in here is a text mining person on some level? Is that? Yeah. Okay. So none of this should be a surprise to anyone, but these are kind of the three kind of high-level buckets of things that we do, which you guys should be well versed in. Document classification is a common tool for us. So oftentimes, and we use document classification in a number of different scenarios. Like if we want to just figure out whether it's worth investing in a deeper analysis of a particular sentence, even we'll do a classification. We have certain signals that we're interested in that are more conducive to classification techniques, like whether a discussion message is kind of heavily opinion oriented or suggestion oriented or information. I'll get into it in a bit, but in general, it's I have a slide on some feature engineering we do, but it's a combination of structured knowledge, and I'll go through how we words. It's also entity information. With respect to information extraction, in order for us to conclude the kind of things we need to conclude, we need to know what things are. So entity tagging is important. Some of the signals we're trying to get. So, we want to know if a treatment is mentioned as being effective or not effective, safe, not safe, cost effective, whether it's a promising new treatment. In the case of research articles, in the case of discussions, we want to know, if someone is speaking positively about a treatment, negatively about a treatment, whether they're on a particular treatment or suffering things that require us to know, that someone's talking about a treatment or they're talking about a condition. So we have a fair amount of entity tagging involved there. And then finally, in order to get those kinds of relations, understanding some grammar is important. Go through a deep dependency tree extraction. Yeah, so on the research stuff, we're using the Stanford parser, and on the discussion processing right now, we're using the malt parser. So we try to create common interfaces so that we can swap out parsers when we need to. But we're moving more and more towards a model where we start off lightweight and we kind of go deeper and deeper as we strategically work. Let's see. I'll jump in with a demo now. How's it going? Armand actually was an intern at Medify for a summer, so you might recognize some things.
I need to first do the stop sharing and then.
Stop sharing. Share my screen?
Yeah.
Desktop. Do I have to use Safari at this point? That should be good.
What you're using there.
All right. So this is kind of a high-level Medify entry point. Oftentimes users enter with a treatment or condition, so I'll go ahead and start off by jumping into a particular condition. So I'll point out some things on the site, and then later on when we jump algorithmically, I'll kind of point out how things are happening or in context. So one of the things, there's some anchoring information here, some definition info about arthritis. So we're bootstrapping our knowledge base from UMLS, which is put out by the NIH. So we've got a few million treatments and conditions and symptoms and demographic information. So that's one piece. The other thing is we have this kind of high-level pivot. So we really break things down based on what health experts are saying and what patients are saying. And so from a health expert vantage, as you guys know, every day, physicians, researchers, and other healthcare practitioners are publishing in incredible peer-reviewed journals. And so that is kind of one of our main corpora. And then the patients are with the online discussion. So I'll jump in a little bit on the health expert side first. One of the things we look at are trending treatments. So as we analyze this corpus, we're looking at treatments and their historical publication rates to get an idea of what new treatments are of interest to folks publishing. We have a notion of strength of evidence, which takes into account a number of patients in a study, academic credibility, institutional credibility, that kind of thing. Here's an example. So we also maintain a semantic type understanding, so we know treatments are alternative or whether they're devices or medications versus therapies. That we're able to kind of slice things up that way. This slide here is kind of what I'll spend most of the time talking about, is how we build this kind of a data. So we're automatically determining a number of signals that I mentioned. So whether something is effective or not effective, safe or not safe, and exhibiting a side effect, etc. So oftentimes when researchers publish these articles, they've got an entire article, and then they summarize it in the form of an abstract. And the abstract's typically between about 5 and 10 sentences in length. And we're interested in a particular category of these where somewhere in the abstract they'll say something like the following. From this research, we conclude that a 25 milligram bolus of tamoxifen combined with docetaxel drip proved to be highly efficacious in females between the ages of 32 and 38 for recurrent malignant cancer. And from that, we basically say tamoxifen is effective and docetaxel is effective for recurrent malignant cancer. And so that's the trick, is to like, that's the kind of problem we're trying to solve. So for any of these, we can kind of click through and get to the actual studies. So in this case, I click through and get to sort of a more advanced search interface with its default kind of pre-populated depending on the entry point I entered. And so these are meant to be read left to right. So display studies where infliximab is effective for arthritis. And so you can also pivot on safety and effectiveness and some other pieces. So if we look in at another one here, adalimumab, we can see sort of a high level of the number of patients studied in these results, the number of studies. And then we can get a flavor for the kind of variation in language. So this is, again, research study, abstract, particular conclusion sentence. And so that's where the reason we think adalimumab is mentioned as being effective is due to this sentence. So in this case, it effectively reduces the rate of something bad. And the other one effectively reduces, again, signs and symptoms of something. So when something reduces a symptom, that's considered a sign of effectiveness. Sometimes they just come right out and say it. This is one of the abnormally simple statements where it says it was effective. Again, reducing a symptom. So lots of different permutations. Sometimes they'll say that treatment X induced apoptosis in malignant cells. So this ability to kind of understand these relational patterns and then reason on them is one of the keys. Yeah.
So are they able to, how do they?
Yeah, so there's a feedback module on the right here where there's like a high level module, and they can enter in right there. We also beg them to tell us when things are wrong, which they do. We also have a notion of annotators, the role of an annotator internally, and so those folks get a different lens on the page, and they can jump in anywhere and annotate, and their annotations actually override the system annotations in display. So. Right now, they're ranked on how confident we are in saying that they're effective, because that's the safest. We decided to err on the side of not showing things that were just wrong at first, and that's just a choice that has to be made. And then you can of course click through, and you get to not only sort of a summarization of the abstract itself, and you can see where the sentence was that we actually thought. You can also get to the full abstract, which is looks something like this. And this is an example of our kind of more involved entity tagging or information extraction linked up with knowledge. And I'll just tell you a little bit of a story about this. One of the founders of Medify, his daughter was suffering from a really serious ailment, which was kind of the inspiration behind starting the company. And so he and his wife, they just found themselves kind of navigating this very complex medical landscape due to the complexity of her illness. And so they started off like most people out on WebMD and these kind of fluffy sites out on the web, and they quickly wound up on Medline or in actual research. And so they realized that how do you actually understand this thing? And so they went around and finding other patients, other folks in similar scenarios. And at one point they asked this woman, well, how do you actually go about reading something like this that's so dense and one word at a time? And I think that's really that's kind of the inspiration behind some of this functionality is, really anything that's not normal English that you would encounter as a normal human who's not in this world, we try to give you some information and help you navigate.
Where does that come from? Is that from
This is UMLS data, yeah, primarily, but then again, we sprinkle on top our own things that are missing. So let me jump back into arthritis, and we'll now look at the what patients say lens. So again, like these are everyday, patients suffering from, myriad ailments are off discussing things on websites all over. And so we're mining those. Right now, we're mining about 500 discussion forums, but we're increasing at a rate of about 150 a week. So so we should, and we're trying to increase, and we're also increasing the rate at which we increase. So we should be by the end of the year hit them all. But basically, this is kind of what patients who have arthritis. So somewhere within a discussion thread, all of the replies, that form this tree are we're referring to as messages. And so somewhere in a given message, a patient said that they have arthritis and they're experiencing a symptom. And so these are the sort of things that they're experiencing given they have arthritis: pain, flare-ups, fatigue, inflammation, back pain. And we find that these are often different. They overlap heavily with what the healthcare experts are saying and what comes out of an FDA trial. But they're different because patients have a different way of speaking about things. They have a different sort of set of things that they hone in on. Oftentimes they can be really annoyed by something like the taste of a pill, right? That can be considered bitter. And that could be something that was just completely trivial from an FDA vantage, but it leads them to under-medicate. And so therefore they're not adhering to their medications on time, and therefore it actually ends up being a serious problem. And that's the kind of stuff that that comes out here. The other thing is, given that somebody has arthritis, what are the treatments that they're undergoing? And that's a listing. This chart's slightly more interesting. It's given that that patients say they have arthritis, we look at the sentiment of them discussing particular treatments. And so, for example, if they're mentioning a treatment and saying outright that, oh, I love my methotrexate, it's totally helped my condition, that's considered a positive sentiment. But also if they're saying that it decreased a symptom and a lot of the other stuff that we talked about with respect to efficacy, that's all considered positive. And similarly, with respect to negativity, if they express a significant sentiment around hating or disliking or a treatment not working for them, those all get penalized as well, or if it's causing a flare-up or a symptom.
Have you dealt with
Mm-hmm. Yeah.
How did you go about finding?
Yeah, I'll talk about the knowledge base in a little bit, but basically the general model is bootstrap with UMLS, which gives you kind of the formal synonyms for treatments, conditions, symptoms, everything we're looking at. But then in addition to that, as people discuss on forums, they have their own permutations. And so we have kind of a bottom-up approach where we analyze corpus level statistics, stack rank, and pump them through a curator human who then adds to it. So that's how you'd find something like RA, meaning rheumatoid arthritis, because UMLS is not going to include that. In this case, I think it's a message. Yeah. So here we see so what we're showing here is the relative ratio of positive to negative sentiment relative to peer treatments. And so we see, at a glance that for arthritis, physical therapy and exercise therapy are spoken about relatively negatively, which is surprising because in most other cases it's the opposite. And that prednisone is also negative relative to methotrexate. And so we can dig in and see exactly why in a second, and I'll do that. Some of the other signals we look at are terminated treatments, so specifically people saying, I quit exercising or I'm no longer on methotrexate. Replacements, they're saying like I switched to treatment X, and then we look at the top discussion forums so that we can help guide folks off to wherever they want to go. This pivot is all around arthritis, but we have this sort of general information space is going to bubble up if you pivot within a treatment lens. So if we go through like prednisone, we'll wind up with a lens, or if we go through treatment for condition, so prednisone for arthritis would have another lens. Kind of basically the same stuff, or similar stuff, but a little bit different. So if we click through now on any of these, we end up again at in an advanced search interface, which is again meant to be read left to right. So this is showing discussion messages with patients speaking negatively about prednisone. And we can, again, pivot. So we could pivot on this first piece and just look at discussion threads. We can just pivot here, and we'll see kind of some kind of entry to all the graphs I just showed you in addition to a few others, like looking at diet and exercise changes or medical history about something. So if we, yep.
Question online.
Sure.
It would be interesting to see the treatment sentiment rate.
So that brings up a good point, which is like, right now you have to get in here and read these things, right? And so the next step is to start bubbling up some kind of summarization across, what everyone's saying. So given that they're saying something negative about prednisone, how do you summarize all of that content? And we haven't quite tackled that yet, but that's a good point. Yeah.
Yeah, especially with prednisone. Positive, so
Yeah.
what does that mean?
Yeah, that's right. I mean, I think that, a lot of times we are raising as many questions as we're answering, if not more. And that's kind of, I think, well, let's go through a few of them, and you get a flavor for the kinds of things people are saying. You do get a flavor for it pretty quickly, but the next step is definitely to start to analyze this and bubble things up, so you can say, well, yeah, of course they're complaining about that because it's right. But then, and you can tease out the things that are actually surprising or interesting or novel. And again, a lot of that depends on your vantage. But this first one here, so this one's classified as negative because the statement says the med has caused many people to become diabetic. This is interesting because nowhere in this sentence is mentioned the word prednisone. So if you expand here, you can see that our anaphora resolution is linking the med to prednisone, stated in a prior sentence. So I'll talk to you a little bit about the anaphora resolution approach in a moment. Some of the other information, we do some summarization across the discussion thread. So this thread is primarily about prednisone, aspirin, arthritis. And it's basically just bubbling up term counts across the entity identification. So nothing too sophisticated. Again, in this case, this person is saying it's caused a bunch of problems. The second one saying, the third one saying, they're actually talking about prednisone causing weight gain. But this one is a good example of what makes sentiment challenging. Is this one's actually a false positive because they're saying, it kind of gives you a little bit of flair as to the nuance in the language. So it's definitely a blunt instrument. But the idea is like across a large enough body of results, you start to zoom out. But yeah. And then here's another anaphora case. It also causes many other serious problems. So that's what's kind of honing in on it being negative. And of course, in the prior sentence, they said something positive. But let's jump back into demo. So do I hit stop sharing?
So you want to go back to
Yeah.
stop sharing, and then under that.
Cool. Well, we don't want anything too smart. All right. So. Yeah. How do we mine text? So our general approach is, we've got a knowledge repository that we bootstrap via UMLS, and then we really strategically use our human resources by feeding them some statistically significant guiding via a corpus level analysis. But basically, I'm going to kind of talk to you a little bit about how we went about this discussion data and give you a little bit of an insight into kind of how it works in like a startup and in a product world, because it's quite a bit different than in the academic world. But basically, you know, we needed to get something going to see if we could do anything, and that's kind of in the next slide. But we have a curator who's got some knowledge, and so that's bootstrapped via UMLS. So we're not going to, at this point, for example, have RA being a synonym of rheumatoid arthritis. We build a parser that's kind of our general language parser with knowledge coming into it via UMLS, and we start feeding it random examples from some particular thread that we want to deal with. And then the parser, you know, starts outputting something, and then we hone in on the stuff that it does particularly poorly at, because that's kind of more interesting than what it does well at. So yeah, we're not after building self-esteem of the parser. So we take the negative examples and we pass them back through. We modify the assignments that we give to the humans, and then the humans give us more examples. And so we're following this kind of active learning model where we're not just we're also guiding the examples we get so that we can change them. And the parser starts to improve over time. So, you know, over the course of, you know, a year, like we're trying to drop new versions of the parser every couple of weeks. So we get sort of this and then, of course, we package up the parser and we parcel it off, you know, into hundreds of machines out on AWS land, and then we're able to index, you know, these millions of documents and take all of those relationships that are extracted and search them. So all those page modules that you saw on the demonstration in the so this, I think, is something that you might not see in kind of from an academic vantage, but like how you actually choose to get training data is interesting from a company vantage. So you know, we follow this combination of supervised and unsupervised. So unsupervised learning helps us guide what we send to humans to give us supervised data, which we then train on. And so we found that in general, building like the ability to provide annotations into the product itself has a number of advantages. And one of them is that it's just a lot easier for people throughout the organization itself to give us feedback, or if we want to bring in contractors or somebody in the system, it's easier to do that because yeah. For another thing we find is that a lot of folks within a company are just simply uncomfortable with this idea of error rates, especially when it comes to health, right? And so we've just found, like, when people, you know, start freaking out about, you know, an error because it's like the number 3rd result, and or maybe it's not, maybe it's on page 9, you know, and for whatever reason, it's the most important thing in the world to them. Being able to channel that angst productively is quite helpful, because otherwise it'll drive you crazy, because you'll sit around constantly trying to explain how, well, you know, this, like how you go to this kind of controlled statistical process to improve the product, and they don't care because they just care about that one thing. So just let them fix it, and everybody's happy. So there's that. And the other thing is, you know, it creates kind of a biasing effect where you're really channeling the ground truth generation to the areas of the product that have more eyeballs on them. So it's decreasing the perceived error rate, and that's surprisingly important, right? So for things that are in the top 5 results or that are above the fold, they're going to get a lot more ground truth definition. And finally, you know, we do in some cases actually override high visibility system mistakes with the actual human data, but it's not a strategy because we have billions of annotations coming out of the machine, and, you know, so just a quick slide here. When we started off doing this discussion mining, really we didn't even know that we were going to pull it into the product. We thought this is kind of an exploration. Some of the folks on the business side said, gee, wouldn't it be cool if we could analyze discussions, and that's kind of about their contribution at that point. And so we said, okay, let's see what we could do. And so part of it was sitting down and kind of grabbing some of, so we wrote a little grease monkey script to hijack some of our pages on our own discussion forums because we didn't have to tackle the problem of you know, parsing the HTML and converting it into you know, our own. And so we started off, we didn't even really know like what exactly signals we would go for, right? So we had a sense of what was important, and we had a sense of what we could do. But the real trick is you just have to sit down and start reading these things, you know. And like when you put yourself, you know, into the data, because at first I didn't know. I mean, for all I know, people are talking about their kid's soccer game on these forums. So, and everyone's just under this illusion that it matters. So the first thing we did is, we sort of ran some entity tagging analysis across the corpus. Okay, well, they're talking about treatments and conditions. That's good. And then we started putting together some signals. So, for example, we thought, well, gee, it looks like people are being pretty opinionated, so we'll throw an opinion signal in there. It looks like we could probably get something out with suggestions. Looks like people are mentioning being on treatments, and they're talking about them kind of negatively or positively. So we kind of threw a lot of those out there. And then we had the product side saying, we really want something on newly diagnosed. If you could tell us when somebody's newly diagnosed, then we could kind of hold their hand and shepherd them through the process. So we said, okay, well, let's see if we can find some of those. We spent some energy, and eventually we found some. But there's a lot of stuff happens at this point. So when you're forcing the human annotators to gain some kind of agreement, you're clarifying the definition of your labels. And so, one of the things that we found out pretty quickly was that just saying somebody is on a treatment wasn't sufficient, because a lot of times people are saying that their husband or their wife or their daughter or their son, is on a treatment, or they're saying that some friend of theirs is on a treatment, or they're just saying you, and we didn't want to deal with figuring out who you was. So we said, okay, let's break it up, and let's say which one it is. So this kind of friends, family, personal vantage became important. Another thing then, so once we gathered some, let me just kind of. So once we started gathering some ground truth, we made a pass through. We said, well, let's look at the data and see what the distribution looks like across these signals. And we found, okay, people are actually talking about meeting substantive things, like the number one, some kind of delivered information, like, hey, check out this. This is more information you check out on a treatment, on a condition. A site, medical history. People talk a lot about their family histories and their medical histories. About on a treatment. So the fifth most significant signal. So we thought, okay, that's interesting. And the things that some of the things that we thought really mattered, at least the business side did, was whether somebody was newly diagnosed. That was way out here. Well, there's just not a lot of that conversation going on, so we're not going to bother. So that's kind of was part of the process. And we kind of rolled it up a little bit, and we said, well, this is the same data, but kind of looked at a higher level. It turns out that there's a lot of conversation about medical history. Statement around a treatment. A lot of kind of folks helping each other, influencing other folks, and then lifestyle adjustments was about 6% of the conversation. So people talking about diet changes. This was all in diabetes, so that stuff's big there. And exercise changes. So, okay. So that's kind of a little bit. Come back into the system itself. Somebody asked about how we define knowledge in a system. So we bootstrap with UMLS, and as you guys may know, UMLS has tons of things we don't care about. We don't care about fruit flies. We don't care about mice and mouse models. We don't care about genes and proteins and chemical compounds. We really just care about treatment, symptoms, conditions, demographics on humans. So that kind of reduces our space of UMLS. And then on top of that, we have kind of our custom contribution with respect to the research abstract data and with respect to the discussion data. So with respect to the former, knowing that highly efficacious, is referring to effectiveness, or that well tolerated is referring to safety. That's an example of knowledge. Discussion side, knowing that RA or BC, are synonyms for rheumatoid arthritis and breast cancer, respectively. That's kind of take a pass. We wrap it up in an API. We do some analysis across the corpus, and then we stack rank things and we shove them in front of a human again. And we say, okay, now walk down this list and start adding. And so then that's what they do. And that's where you quickly find out that, like, yes, occasionally people refer to rheumatoid arthritis in this obscure way, but for the most part it's RA. That helps us distill things. So some key things that are in the knowledge base is identity. So we maintain UMLS ID. So that's what helps us. Like when we saw that overview paragraph, that's how we do that matchup with our taxonomical relations are important. So hierarchical is our relationships. We need to know that rheumatoid arthritis is a type of arthritis, which is a condition, so that when you're sitting on the arthritis page, you'll be able to see instances of all the arthritises, even those that don't have the word arthritis in them. Similarly, you can go to just the rheumatoid arthritis page and just get references to that. We talked about synonym relations. Polarity is important, knowing that effective has a positive polarity relative to ineffective. Those are important if you want to conclude that something's effective versus not effective. If you don't have polarity, you've got a good chance of butchering it. Parsing clues, so with respect to kind of the more statistical techniques or the machine learning techniques, this is helpful. So in order to figure out sentiment, something like I feel or synonyms of I feel is a nice engineered feature that somebody was asking about, like bag of words, rather more. So we built out a little system that helps you like very kind of tersely define phrases and then kind of link them off to synonyms, and then we basically go through WordNet and we kind of walk out and come up with kind of larger synonym lists, and we pass those through a human and we kind of narrow them back down, and so we're able to get like lots of permutations for have you considered, which would be a suggestion. And then anaphora clues are another thing that we use humans for in the knowledge base. So for anaphora, knowing that a drug or a pill, refers to a treatment, but more specifically a medication, whereas a machine may refer to a treatment and more specifically a device. That's all important. And so a little bit of kind of the anatomy of one of the parsers. This is the abstract parser. So we start off with a document, in this case, a research abstract, and we step one is to split sentences. And once we split sentences, we go through a light entity tagging approach, which is basically n-gram, word-gram approach with a bias towards the long arrow matches. And then we go through a sentence modification step. So if for anyone it sounds like most folks in here have worked with deeper parsers, but as you guys know, the more grammatically simple the sentences, the better the efficacy and the faster the parsers perform. And so there's two great incentives to really spend some time there. This is probably one of the most valuable steps in the system with respect to so being able to, so we have a lot of, we have kind of three main categories of sentence modifications. Like in this, one of them is, this conclusion sentence typically say, something like, from our research we have found that, or our studies show that. We just get rid of all that because it's just going to confuse the parser. The other kind of class of things are kind of complex verb or predicate statements, like X was shown to highly shown to be a much improved version of, which you could just substitute for outperformed. So you're making that whole kind of phrase, simplifying it. And then finally, being able to address the noun phrases and map them into just a very terse one-word token that the parser doesn't understand. So being able to take malignant recurrent cancer and swap that out with with a one token word that the parser doesn't know about. Pardon?
I was still the error on, so I was thinking about that now. Like that's not an easy one to parse.
So the output of the modified sentences, then we go in and we parse. In this case, we use the Stanford dependency parser, and then we take those type dependencies extraction process. So at that point, we're really trying to get down to like subject verb object style, SVO style, compact triples. So that would be something like X reduce Y. Toxin reduces vomiting. So you're trying to get to this very compact triple. And then we have another rule engine that fires to then make conclusions. So that treatment reducing the symptom is maps to effective. A treatment inducing. And so at that point we have a conclusion. We don't know how good it is, and so we need to assign a confidence to it. And so we have a number of features that go into the confidence assignment. Some of the key ones are sentence length, crude measure of sentence grammatical complexity. We actually use that too, which is sort of the output of the dependency tree, like how many. Knowing what exact rules fired in this case is another another indicator. Knowing what the actual output signal is another indicator in confidence assignment. So if you back up to steps 2 and 3, we actually go even further. We follow kind of a whole parallel universe where we do this 3-tier kind of bag of words style classification, which doesn't use the deep parsing ability. And what that's and so what we do there is we follow this approach where tier 1 is like grab appropriate sentence. Tier 2 is like, is this about effectiveness? Is this about safety? Is this about something else? And then tier 3 is like, given that it's about effectiveness, is it saying it's effective or not effective? And so that's step. And so when we're all done, we know we have a sentence, and somewhere in it is something saying something is effective. So then we have some heuristics to try to figure out what that something is with the treatment. And at the end of it all, we spit out something comparable to the other flow. So the other flow is the back, like the workhorse, and this is kind of more like occasionally this approach gets lucky and gets something that winds up with a high enough confidence to make it out. But for the most part, where it overlaps with the parser, it helps out a lot for confidence. And so because it's following kind of a different technique. And so we found that helpful. How much time do we have? 2 minutes. Oh, okay. So the discussion parser is quite similar. So I guess with the added kind of, we're doing some anaphora resolution on the discussion parser, and we haven't yet deployed the anaphora resolution on the research side. So we talked just 2 seconds on feature engineering. We go through and normalize. So normalized synonyms are helpful for engineered features. I think that the main advantage for engineering features is that you don't require as much training data to perform reasonably well. So, for example, if we know all of these synonyms are basically saying the same treatment, then even though our training data may have only had 1 or 2 of them, the model is still going to apply. We also, oftentimes add in new things as we encounter them. So, for example, when we're building the diet and exercise classifier, quickly realize that food's a big deal. And so when you start, looking at your actual key terms, so then we said, well, let's just pop in a whole ontology or knowledge food. And, that's an example. Entity types are important. So knowing that metformin is a treatment and a medication, that feature tends to perform pretty well. So we spend a fair amount of time engineering. Then we talked about the phrase-driven cues. So like the have you considered, synonyms of have, synonyms of use, synonyms of considered, passing that in as a suggestion indicator. A little bit on anaphora resolution. So I showed you some of those examples. So relationship structure is important. So knowing that like a person takes it in this relation structure, people typically take medications, but they don't take devices unless, I don't know, they're taking them across the country, relevant, and they don't take therapies. So that's an important thing in resolving anaphora. Is everyone familiar with anaphora resolution? So we also look at things like, so we take this approach of trying to determine, well, what are the anaphoras that we're trying to resolve, and we try to do that in a statistically meaningful way. So we look across the corpus and we pass through humans so that the human can say, well, you want to resolve drug, you want to resolve pills, you want to resolve regimen, you want to resolve bolus, all these things, and so then they're performing that mapping. So they're saying, well, drug maps to a medication of sorts, whereas device matches, whereas machine matches to device. Filtering, so of course you want to filter non-matching antecedent candidates, so things that don't have the appropriate type, look for singular and plurality agreement. And then as far as scoring goes, looking at like the occurrence of the antecedent is important. So if you just have like, one mention of an antecedent, that's going to score lower than a bunch of repeated mentions. Looking the distance, the number of sentences from the antecedent to the anaphora. So if you're back 1, 2, 3, 4, 5, 10, 20 sentences, that's going to have a progressively degraded effect. And the co-occurrence of the anaphora with the antecedent is also really important. So knowing that it doesn't have to be in this sentence, but at some prior sentence that these things co-occur, that's also a good indicator. technology, this stuff. A lot of work to distribute the parsing and get it to the point where we can actually build out an index. And then finally, the ability to search, request transaction. Sorry, we ran over.
I have one very important question.
Yeah, sure.
Which is, are you guys looking for?
Just email me. We're always looking for interns right now. We're not, but hopefully very soon. Cool. Yeah, just feel free to email me. Check out the site, play around, fill in the feedback thing, or email me. I'm just ddillon at Alliance Health.